Hi, welcome back. I have my assistant here again today, Ariana, and she's going to help us talk today about section 10.1, which is trig identities. Now, this is in part one, we're going to be talking about some fundamental identities, and you might remember that on Monday's class, our last class, we talked about a few identities, and I defined what a trig identity is, and a trig identity is an equation that relates trig functions and is true for all theta, or sometimes maybe if we're using like sine of x or sine of alpha or something like that, whatever the input is, but is true for no matter what input you plug in that makes sense. Okay, and we talked about these fundamental identities over here. We have two that are called the quotient identities. Tangent of theta is sine of theta over cosine theta. Cotangent of theta is cosine of theta over sine theta. And then we have three reciprocal identities. Cosecant of theta is the reciprocal of sine, so cosecant of theta is 1 over sine theta, secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. These identities we derived, and we showed how we got these identities. You want to memorize these identities. You want to get really comfortable with them, because when you go on to your other courses, especially those of you that go on to take calculus, there will be times where you have some of these expressions that are down here. You have them, and you're going to need to replace one expression with another one. So knowing these fundamental identities like the back of your hand is going to be really important. So the rest of part one today is we are going to talk about two more collections of fundamental identities, the even and odd identities and the Pythagorean identities. So let's start with the even and odd identities. Okay, so the even odd identities, these are called even and odd identities because it has to do with an even function versus an odd function. And you might remember from college algebra that an even function is a function that is symmetric about the y-axis, and the technical definition is that f of negative x is equal to f of x for all x's. And our odd function is a function that is symmetric about the origin. And so what that means is, in terms of algebra notation, f of negative x is negative f of x. Okay, so those are kind of definitions of even and odd, but let's talk about what that means in terms of trig functions. So let's start with our sine function. So we have y equals sine x, and if I were to draw a picture of the sine function, I know that the sine function, one period, looks something like this, starts at the origin, goes up, comes down, and goes back up, and maybe I'll draw one period to the left as well. And if I was really concerned about this, I could mark all four labels. I'm just going to mark a couple of the labels on here, negative 2 pi, negative pi, 0, positive pi, and positive 2 pi. Okay. And what I notice about this function is that this function is symmetric about the origin. That means that if I want this to match up, I need to fold across the y-axis and then fold across the x-axis. So our sine function is an odd function. What that means is that the sine of negative x is equal to negative the sine of x. Okay. Now, in terms of the symbols, that kind of makes sense because down here we have our odd function. The name of our function is sine, but a generic name is f, so sine of negative x is equal to negative sine of x. In terms of the picture, if I think about what's happening, let's say I'm looking at pi over 2. So, for example, sine of negative pi over 2, here's negative pi over 2. The sine of negative pi over 2 is negative 1. And negative the sine of pi over 2, here's pi over 2, sine of pi over 2 is 1, so we have negative 1. So sine of negative x gives us the same value as negative sine of x, and that's true no matter what angle you plug in. Okay, so this is our odd identity. The sine of negative x is the same as negative sine of x. Okay, let's take a look at cosine of x. All right, so the cosine function, if I draw one period, starts high, drops down, and pops back up again. And one period off to the left does the same thing. And I'm going to mark a few important pieces, negative 2 pi, negative pi, positive pi, and positive 2 pi. Okay. And our cosine function is one of our even functions. If I fold this graph just across the y-axis, it exactly matches up. So the cosine function is an even function. And when we talk about an even function, if I put a negative in front of the x, that's exactly the same as completely ignoring that negative. So cosine of negative x is the same thing as cosine of x. All right, so for example, if I look at cosine of negative pi, so here's negative pi, our y value is negative 1, so cosine of negative pi is negative 1. Cosine of positive pi, here's positive pi, the y value is also negative 1. So cosine of negative x is exactly the same as cosine of x. So that's our second even odd identity. Okay, so our third one and our final one of these even and odd identities is for tangent. Now, we just talked about the tangent function last class, so let me remind you about that one. If you haven't gotten this one down yet, you definitely want to get some good practice at drawing the tangent function. So let's see, I'm going to mark all 4 of the important points in both directions. So negative 2 pi, negative 3 pi over 2, negative pi over 2, positive pi over 2, positive pi, positive 3 pi over 2, and 2 pi. And for y equals tangent of x, we have vertical asymptotes at negative pi over 2 and positive pi over 2, negative 3 pi over 2, positive 3 pi over 2. And in between those vertical asymptotes, we have what I like to call spaghetti branches. So this graph that kind of starts low and pops high and goes through the x-axis halfway between the 2 vertical asymptotes. And so here is a sketch of our tangent function. Okay. Now, this tangent function, in terms of the symmetry, if I fold this tangent function across the y-axis, it doesn't match up exactly. But if I fold across the y-axis and then across the x-axis, the tangent function does exactly match up. So the tangent function is one of these odd functions, which means that having the negative next to the x is the same thing as moving the negative to the outside. So tangent of negative x is equal to negative tangent of x. Okay, so these are the 3 even and odd functions. There are some for secant, cosecant, and cotangent as well. You can look them up if you're interested. I don't think that I have ever in my life used them, so I wouldn't worry too much about them. But these 3 even and odd functions are important. We're not going to see this right away where we'll use these, but this idea of I can move this negative from inside the parentheses to outside for the sine function, or I can completely ignore the negative sign for the cosine function. Those things are going to play a role for us in the near future. Okay, we're going to pause here. When we come back, we'll talk about the Pythagorean identities. Thanks for listening.